Hi everybody, this is lesson 1, generating equivalent expressions. Our essential question is, how can we simplify expressions using like terms? Okay, so hopefully you've heard the phrase like terms before, and we also define that later on in the video. So we're first going to start with this page of vocab words. Now, when it comes to vocab words, I'm not so concerned with can you rattle off the definition rather than understand what it means. So what I'm mostly concerned with is, can you explain to someone near you, a little brother or sister, back to me or your parents, can you explain what a variable is? If you can explain it in a way that someone else understands it, then you really do know what the word means, which in my opinion is more important than memorizing the actual definition. So in order to do that, let's talk about what each one of these means. Variable. You've definitely heard of a variable before. It is a symbol or a letter that represents a number. So we can see that if you want to, you can write here or in your margin. Example, we use like X, Y. Sometimes you'll see like 2A. So A is the variable. So you've definitely seen that before. Again, anytime that you need to pause this and copy down things, that's definitely what you should be doing with the video. Okay, numerical expression is a number or combination of sums, differences, products, or divisions of numbers that evaluates to a number. Evaluates is kind of a fancy word of saying equals, so it equals a number. And then, of course, you know that sums, differences, products, divisions, you know which symbols those should be. So a numerical expression is just using numbers, and then it equals, it's kind of like a number sentence if you think of it that way. And then the value of a numerical expression is just the answer. Okay, so you can say AKA the answer. Sometimes when you take tests, whether in class or on the map test or the park test, you may see terminology like that, like evaluate the expression, and you're like, oh my goodness, what does that mean? Oh, it just means solve it. Okay, so don't get tricked up by the fancy wording here. Okay, expression, a numerical expression or a numerical expression with some of the numbers replaced with variable. So if you notice, we went from value of a numerical expression or a numerical expression to just expression. So expression, it includes numerical expressions, but it also includes those algebraic expressions that have variables. Okay, so it's really just a number sentence that includes variables. Equivalent expressions are two expressions that evaluate to the same answer. So think equivalent, equal, which means the same. So that would be like 2 plus 5 is the same as 3 plus 4. That's a very, very simple visual on what that means. Okay, an expression in expanded form, it's an expression that can be simplified. So if you have 2x minus 3 plus 4x minus 5, well, that can be simplified because you have like terms, and that's what we're getting into in the next two definitions, which are term and like terms. So a term is a single number or variable. So a single number or variable could be 8, or it could be x, or numbers and variables multiplied together. So not 8 plus x, but 8x would also be considered a term. Okay, now if you had 8 plus x, that's 2 terms. 8x is 1 term. Again, you always pause it if it's going too fast, and go back if you need to hear something again. The coefficient of the term is the number being multiplied by the variable. So I typed out two equations for you, and if the number being multiplied by the variable is right next to the variable, because there's nothing in between it. So if you look at 4x, and then over in this example, 2x and 4x, the 4 is the coefficient. The 2 is the coefficient. And then here, the 4 is the coefficient. Okay, and I apologize, I just skipped right over like terms. That was one that I wanted you to add in. That's terms whose variables and exponents are the same. But it's okay that I skipped over it because the segue is actually right here. 2x and 4x, those are called like terms. So 2x and 4x are like terms. So 2x plus 4x, because they're both positive, equals 6x. So you can actually write it like that. You're combining them. Okay, and then the last one is an expression in standard form, and that's just simplifying it as much as you can. And 2x plus 6x could be simplified to 8x because you have a positive 2x and you have a positive 6x. They are like terms, and you combine them to make 8x. Again, a lot of these examples are simple just for you to kind of get an overview of them. Okay, we're skipping all of page 3. And then we're going to actually skip the top of page 4. So if you can jump over to page 4, don't cross out the blank area, just cross off the questions here, because that's a continuation from the last one. But I have some things that I'd like for us to do up there. Okay, example 1 says, rewrite 5x plus 3x and 5x minus 3x by combining like terms. Write the original expressions and expand each term using addition. What are the new expressions equivalent to? Okay, so if we're going to expand, we have 5x plus 3x. If we're going to expand that, it's going to look like this. First we have 5 x's, so x plus x plus x plus x plus x. And then 3x, we have 3 more x's, and they're all positive, so it's still plus x. Okay, so altogether we have 8 x's. So 5x plus 3x is equal to 8x. Okay, what about if I had 5x minus 3x? Well, let's see, I have 5 x's, x plus x plus x plus x plus x, and then I minus 3 x's, minus x minus x minus x. So I have 5 x's, I take away 3 of those, and I'm left with 2x. Now you probably saw a simpler way to do that because they are like terms, so feel free to do that. There's a couple other ways that you can do that. If you want to look at this one, again, 5x, x plus x plus x plus x plus x. Okay, this is equal to 5x. And then you could look at this as 3x, and if I'm taking that away, I'm just left with x plus x, which is 2x. Okay, let's find the sum of 2x plus 1 and 5x. 2x plus 1, and remember, and we a lot of times think we're combining those, so that means we're going to add 5x. Okay, for this one, go ahead and try that on your own and see if you can figure out what that is. This has to do with combining like terms. Okay, did you know that you could combine the 2x and the positive 5x? You don't have to write it out in expanded form anymore. We won't have time to do that. So that would be 7x, and then I still have a positive 1. So that's all you do. You just write 7x plus 1. Okay, try the last one on your own. I have a good feeling that you'll be able to do this one by yourself. I like to use different colors. So this is negative 3a, and this is positive 5a. So if I have like a minus 3a and a positive 5a, you could think of that as having 5 a's and then you take away 3. So that would be 2a. And then I'm going to use a different color to show positive 2 and minus 3. Okay, if you're good with your integers, you can also be using your calculator in this unit. So a +2 and a -3. So I have $2, but I owe someone 3, so that means I still owe them $1, or I still have a -1. So 2a minus 1. Okay, and that's it for example 1. Let's look at example 2. Find the product of 2x and 3. So product means to multiply. So 2x times 3. That would be like saying, okay, I want 2x and I want to have that 3 times. So that would be expanded form. Again, you don't have to keep doing that though if you know that 2x 3 times would be how many x's? 6x. And now I've just made that one term. Okay, because your definition of term earlier, it was a single number or variable or numbers and variables multiplied together. And 6x is 6 and the unknown number multiplied together. Okay, look over on to page 5. And now we're going to be simplifying these as much as possible. Use any order, any grouping to write equivalent expressions. So here's what we can do. You can do it a couple ways. You can do the phrase 2x 3 times, which is basically what we did on that last one. Even though it's 3 times 2x, it's still the same thing. And then you know that that is equal to 6x. Okay, how about this next one? Try the next one on your own. Now that you've seen the 3 times 2x or the 2x times 3, try the next one on your own. Pause it, write it out, 4y, write it out 5 times, and then see if you can simplify it. Go ahead. Okay, did you write 4y plus 4y plus 4y plus 4y plus 4y? Hopefully you wrote it out 5 times, so that's 4, 4, 4, 4, 4. That's 20y. And that's because we're multiplying it. Okay, on the next one I have 4 times 2 times z. Well, I can multiply all those together. 4 times 2 is 8. 8 times z, well, I don't know what z is, so I can just write it like this because that's how I'll see it written algebraically. Okay, the next one's a little tricky. We're going to take this as 2 separate things. 3 times 2x, so that would be 2x plus 2x plus 2x. Then I have 4y 5 times. So it's basically like we're going to be combining this example and this example. So it'll take us a second, not too long though. If we write it out like this, I think it's going to give us a better understanding of why we can't combine the y's and the z's. Okay, I can combine all these x's. That would be 6x. And I can combine all these y's. That would be 20y. And since it's positive, I put a plus sign in front of it. And that's it. I really can't simplify anymore because now those are unlike terms. So go ahead and write that because you're going to hear that phrase. Unlike terms. I don't know what x is and I don't know what y is, so I can't just combine them together to make a new problem. If it's multiplying, you can write them together, but this isn't multiplying. Okay, so 3 times 2x, we already know from above that that's 6x. 4y times 5, we know that that's 20y. And then 4 times 2 times z, we know that that is 8z. Now, these all have different variables. This is x, this is y, and this is z. Those are all different, so I cannot simplify anymore. But I can just write it like this. 6x plus 20y plus 8z. And that's all you have to write for that one. Okay, Alexander says that 3x plus 4y is equivalent to 3 times 4 plus x times y because of any order, any grouping. Is he correct? Why or why not? Well, what I love to do on these things is I like to come up with actual numbers for those and compare them. So let's write 3x plus 4y over on the left side. And then let's write 3 times 4 plus xy. This is a great tool to use anytime you're taking a test or problem solving. You can actually find out if they're correct just by plugging in some numbers. When I make up, like what I'm going to do right now is make up numbers for x and y, because as long as I use the same number for this x and y as I do for this x and y, it should work out the same according to what Alexander's saying. So what I'm going to do is I'm not going to use the numbers 3 or 4 because that's kind of confusing. I generally don't like to use the number 1 because 1 does some tricky things sometimes, especially with exponents. So I like to use easy numbers that aren't already in the problem. So I'm going to go with 2 and 5. Let's make x 2 and let's make y 5. Okay, let's plug it in and see what happens. 3 times x is 2 plus 4 times y is 5. So all we're doing is just plugging in the x and y. And then I have 3 times 2 is 6, and 4 times 5 is 20. Okay, let's go over here. This one already has 3 times 4, so I can just write 3 times 4. There's nothing to plug in there. Now I'm going to use the same x and y. X is 2, and y is 5. Okay, now that looks like a pretty simple problem. Now, if you look from this row here to this row here, do you think it's going to be the same answer? This is 3 times 2 plus 4 times 5, and this is 3 times 4 plus 2 times 5. He's saying any order, any grouping. So let's see if that works. 3 times 4 is 12, and 2 times 5 is 10, and 12 plus 10 is 22. Is that the same as 6 plus 20? No, it is not. So no, he is not correct. Okay, and the reason is he is switching the multiplying and the adding. So if you're adding 3 numbers, you can switch the order, such as 3 plus 4 plus 5. That's equal to 5 plus 3 plus 4. And then let's say I'm multiplying all those numbers. 3 times 4 times 5. That's the same as 4 times 5 times 3, so I can mix those numbers up. But once I make different terms here, like if I do 3 times 5 plus 4, that is not the same as 4 times 3 plus 5, okay? Because this comes up with 2 different terms. That would be 15 plus 4, and this one would be 12 plus 15. And those aren't the same answers. Okay, so just make sure that you know it's only when you are adding or when you are multiplying. But when you mix them together, you can't just say, oh, I'll multiply the 3 and the x in this expression, but multiply 3 and 4 in that one. It won't work that way. And again, if you're ever confused, you should actually solve it out and see what happens. So even these ones right here, if that kind of went too fast, well, go ahead, actually solve this out and see what happens. 3 plus 4 is 7, and 7 plus 5 is 12. 5 plus 3 is 8, and 8 plus 4 is 12. So there you go. Those are equal. 3 times 4 is 12. 12 times 5 is 60. 4 times 5 is 20. 20 times 3 is 60. So again, if you're ever stuck, go ahead and actually figure out if that property would work or not. Down here, I didn't finish, but I will just show you that this one is 19 and this one is 17. So that means they are not equal to each other. Okay, so that is a wrap on the very first lesson in Module 3.